Okay, I would say everything is running. So, yeah. Um, let's start, guys. Yeah, welcome to this stream, Max and Mikael. This is the second stream we have, or I have on the channel with guests. Usually I'm talking to the chat and myself. So, thanks for being here. Yeah, maybe quickly introduce yourself and talk a bit about how you came to data engineering, and then we get into the details.
Sure. I could start here. So I'm Michael. Hi, everyone. I'm working as a data engineer at Zalando. I am in a team who is responsible for maintaining certain elements of the core infrastructure, the data lake, a data processing platform, and I became a data engineer after first starting years ago as a front-end engineer, then moving towards back-end development and joining companies who are offering products like more and more analytical products. I got interested in everything related to maintaining data sets and data infrastructure. And at some point, I applied to Zalando, where I started working officially as a data engineer.
Cool.
Hi everyone, I'm Max. I already started working in the data space when I was still at university. During my studies, I already got interested in like databases and these kind of things. And I was pretty lucky because I was studying at Humboldt University in Berlin, where there was which was one of the universities taking part in the initial developments of Apache Flink. And this was like one of the first things where I also got in touch with distributed systems, with big data processing. And pretty early, I had the chance because the database chair that I was already working with was part of that. So I grew into that part as well and took part in the initial development of Apache Flink, which was a pretty cool chance for me to already get into this. And actually, I just right after university, I joined Zalando, which was about 3.5 years ago. And since then, have been working in exactly the team that Michael mentioned, working on the data lake since the very beginning, and got into all these things like setting up the general data lake and all the details around data processing platform that Michael also just mentioned.
Cool. Interesting. So yeah, the the paths that a lot of people are doing, or that they're doing, is very different. And I find it interesting that Mikael said he's coming from the web engineering side, and so, or from the web development. So people are more and more interested then, or then developing an interest for this data processing, data storage, data management
Yes.
field. So it's
Well,
very interesting.
I think so. Data engineering as a separate, let's say, profession is like very young, right?
Yeah,
You don't get data engineering. You didn't data engineering, let's say, job adverts, I believe, 10 years ago still, right? Usually you
no,
will be a backend engineer or DBA, right? So the database administrator. And from what I have noticed, people joining data engineering profession are coming from mostly three backgrounds, either distributed systems or backend engineering or DBA, which means database administration. Because you have to be a bit of all of them when you want to be a data engineer. And at the same time, your biggest interest needs to be in the data as a product, right? So when you build a backend service, you actually want to hide data. When you build a distributed system, you are mostly interested in how it, like, in its resilience, or how will it behave under like difficult conditions. But like, when you start focusing on the quality and completeness of your data, when the data is your product, you start becoming slowly a data engineer. And I think it emerged as companies started gathering more and more data that they couldn't process actually.
Yeah, that's true.
The supply of data is still growing much faster than companies are actually able to consume it in terms of insights. So
Yeah,
here
that's
we
right.
are trying to help them.
Yeah, this is a good point. As you said, you want to hide the data, you want to hide the whole back end so that you can make the most of the data and not to the actual user or to the data scientist. And this is why I called this channel Plumbers of Data Science, because it's more or less the background, the stuff you don't see, but that's interesting.
It is plumbing in a way. I also like the term data janitor.
Yeah, that's true.
About the quality and how clean the data is.
Yeah, cool. Okay, do you want to get a bit into Zalando and what you guys are doing?
Yeah, I think I can just give a very brief overview of Zalando as a whole, and then we can get a bit into how the data landscape at Zalando actually looks like. So for those who don't know Zalando, as followers of your channel, Zalando started as a startup around 10 years ago to sell shoes online. And in the last 10 years, actually grew to become the biggest online fashion retailer in Europe. I think in 2018, we had over 5 billion in revenue already, which is quite impressive numbers for a company that's only 10 years old. And the interesting part for us here is that by now we also have over 15,000 employees, of which over 2,000 work in tech alone. And this is very interesting part for us because like everybody who works in tech at some point or the other comes into touch with data. So all of them are potential customers for like centralized data solutions and people who not just need support on how to actually process data, how to actually get data, and how to actually make sense of it. And that's basically where we come into place. So first of all, we are part of a bit bigger department at Zalando, which is called Data Solutions. You can basically envision that a bit as a combination of classical business intelligence with like big data warehouses still running in the data center that have been processing the data for a very long time already, in combination with everything related to a cloud setup of a data-driven company. So this comes with a company-wide event bus. This comes with a data lake, which is actually a part that we are working on. But this also comes with several other teams like a data governance initiative, machine learning support team for all the teams who are getting into that space, as well as things like support teams for setting up databases for various different teams. So there's like various different parts of the department which are working together to provide centralized data solutions to the whole company. And of that whole part, we are working in Zalando's data lake and the data processing platform.
Okay.
Yes, I could maybe show that like some slides that more or less could explain what it looks like from our perspective. Let's join the meeting.
By the way, I first came in contact years ago with Zalando through shoes, buying shoes online.
Yes. Yeah. So when I was interviewed by Zalando, you could still at every table in each building you would see a shoe. That was exactly what it looked like. I was really surprised it was there.
Because at that time the motto was put yourself in your customer's shoes.
Yeah.
Okay, this is a good motto.
But Zalando started expanding, and the shoes became just part of the merchandise.
Yeah, I mean, if you have the platform and it basically doesn't make a difference if you're selling shoes or if you're selling more stuff. Just need the infrastructure is there, and you need to expand.
Yes.
With the whole thing. Right now, are you already presenting? Because I can't see a presentation.
Yes, the presentation is. I am presenting to the meeting. I can try again. I can join and rejoin.
Strange.
Let's try that.
How about now?
No.
Nothing.
Okay.
Strange.
Yes, then Max can try do the same thing as well, and we
Can you
will.
quickly send me the link?
Because it says that you're joining the meeting.
Yes.
When I guess when you click, but then nothing comes up.
Mm-hmm.
Or maybe I'm just
Let's try
useless in in managing this thing here, but.
Oh no, don't send me the link to the meeting, but the presentation.
Okay. There we go. It just proves that this is...
Okay. I guess it was my fault.
Okay. So can you see the presentation now?
Yes, I can see the presentation now.
Okay.
Let me just check if it. Yeah. Okay, it's good. It's all good. All good.
We have here several slides, selected slides from the presentation that Max did at some point at Strata, I think.
Yeah, Strata London.
And they are somehow showing the overview of the part of the infrastructure that we are building.
Okay.
So I would start from the center actually, because the storage part is the actual. This is the data lake, right? So depending on how you define a data lake, it's either the storage plus everything that is around it, or just the storage, right? So Zalando is completely, in terms of infrastructure, like cloud bound, I would say. Not everything yet is deployed in the cloud, but basically 95% of everything that we are running is on AWS. And this means that this is also the case with our data lake. This has a pretty obvious implication that most of the storage is done through AWS S3. Several buckets depending on the data set and on the format in which it is stored. We are still using Hive, Apache Hive deployed in EMR as a metastore. However, we are thinking about migrating to AWS Glue because of the scalability issues with Hive. And on the left side, what you can see is our three main data pipelines that are feeding the data lake, and on the right side, ways to consume this data and discover it. We have three main data pipelines. The first one from the top is transferring about almost 3,000 data sets by now. This is the central event bus at Zalando that is transferring all kinds of information, mostly transactional and operational, but also business processes and parts of the reporting infrastructure. This data is being fed to the data lake for archiving and further analysis by one of the data pipelines. Then we have the data pipeline from the data center. This pipeline is transferring around 300 data sets, like high quality and high value data sets from the operational data warehouse, deployed in the data center based on Exasol and Oracle. So those are mostly relational tables that we also transfer into the data lake for further analysis and for joining with other types of data. And the last one, which is the smallest pipeline, is the one that is transferring the Google Analytics data from a BigQuery to the data lake as well. So this way we are gathering those data sets together and allow data scientists and analysts to analyze it together. That's the most important part.
And for instance, I'm guessing you're also analyzing app usage and so on.
Yes.
Or from your website. This is coming through the event bus, right?
This is coming through web tracking, because all the events related to so Zalando is using Google Analytics for both web tracking and app tracking. I think the app data is also in this data set. So it is enough to transfer this data set, this single data set that is like pretty large, around 100 gigabytes per day. Yeah. So I mean, we are talking about millions of clients and every action being tracked, right, on the website, on the app. So there is a lot of data to crunch. We transfer this data into actually separate pipelines. One is doing like batch processing, the other one is, let's say, like micro batch / stream. They differ in completeness and they differ in the data format. And on the right side of the slide, you can see two ways of querying this data and one way to discover it. Presto is our main analytical engine that we offer to other teams for data analysis, for running SQL queries on this data. We have also a pretty large deployment of Databricks, which is a proprietary and like enhanced Spark distribution, together with a pretty cool notebook environment. So this is used mostly by data engineers and data scientists. And we are now, we have a small data catalog for discovery of the data, but also we are in the process of enhancing it and maybe building slightly more robust than the current data catalog. So this is basically the place where you can discover those data sets and ask for access to them.
Yeah, I'm guessing this is coming more and more and more. Earlier on, people were only working on how to ingest the stuff, how to store it, how to serve it. But as the amount of data grows and the variety of the data that you get, these data catalogs are needed more and more, right?
Yeah, so we have seen this approach from multiple companies now, like Lyft or Airbnb. They are essentially either buying something from a vendor, or they are developing something that you could call Google search for data sets, right? Data sets are being treated as assets, as discoverable assets with like rich layer of metadata around them. And what we have seen in those systems is that not only will they let you discover the data set, its structure, its properties, but also give you relevance in terms of how relevant is the data set could be to you, which data set is most popular because it is queried the most, right?
Yeah.
Lyft, I believe, is using the PageRank algorithm actually to rank the data sets in terms of popularity. So what you get is literally like Google search results for data sets.
That's cool. Okay.
Yeah, so what we could go a bit into is actually have a more detailed look at some of the ingestion pipelines that we're running, and we also have something where we can talk a bit more about this processing platform that we're offering to the rest of the company. I would suggest that we just start with one of the ingestion pipelines.
Yeah.
Yeah.
Yeah,
we have around 25 minutes, I guess. So I'm keeping my questions a bit down.
Yeah.
I don't want to stall you that much.
But what is pretty interesting to see here is just by the logos that are on the screen here, we are actually pretty heavy users of the serverless offerings of AWS. So we are heavy users of like Lambda, SQS, SNS for some other use cases, things like DynamoDB as well. What this pipeline is about, this is the event pipeline that we spoke about earlier. This is for getting the data from the event bus into the data lake, but also doing some data preparation on that way already. The very first part that is happening here is our event bus is who you see here on the left is called Nakadi. It's actually an open source project, and it's basically an API wrapper around Kafka. So feel free to check that out as well. This is a pretty cool project with a very nice web UI as well, where you can actually do some analysis on the events already while they are still in the event bus. This comes with its own archiver, which is basically a very what we call dump. So it just dumps all the data in a very stupid way to S3 in like big batches. There's no clear separation of between single events and these kind of things. So there needs to be a bunch of cleaning before we can actually offer this data to the users. And what is basically going on the data plane is that at first we actually have to explode these files so that one record is actually also one line in the file so that you can analyze them separately. And then we have some specific data pre-processing, like repartitioning or conversion to, for instance, binary format. Right? And how this actually looks like on our side is that we are using Lambda here for most of the processing. And basically, whenever an event ends up in the S3 bucket, whenever a file ends up in the S3 bucket that the Nakadi archiver is writing to, an event ends up in an SQS. So you get a notification that a new file is there. And with this event, you can directly trigger a Lambda again, and then Lambda picks up the file and actually does the processing for you. One pretty cool thing that we turned like somehow into a pattern, which you can see here as well, that our SQS plus Lambda combinations always have a dead letter queue attached to them as well. So whenever something goes wrong in the Lambda, the message actually gets pushed back. There's a couple of retries, but eventually you have to give up, or you will be spamming your Lambdas all the time. They keep on failing if it's non-transient. So the message actually ends up in a separate queue, which is a dead letter queue. And the very thing here is that the dead letter queue can again be attached as an input to the very same Lambda. So obviously per default it's disabled, else you keep on spamming yourself again and over and over. But you can then actually go there, fix the bug that you saw in your Lambda, and you're not losing any of the messages of new files that have been arriving. And once you fix the bug, you just enable the queue. All the messages from the dead letter queue flow in again, and you basically have resilient reprocessing.
Okay.
Because the most important part here is not to lose the messages, right? Every message is an indication that a new file has arrived. So it is fine to be slightly late with the processing. It is fine to be, let's say, producing duplicates, because this can be handled later. However, we need to be complete. And this is the queues are so important. And this is actually a feature of SQS itself. You can do it more or less like very easily, either through AWS API or to the interface, like set it up.
Cool.
Yeah, that's why you see our Lambdas here. They always have two small symbols of SQS on the bottom, which is exactly, it's the input SQS that we're using, and the dead letter queue, which is the second SQS that comes from. And that's why we even turned it into a single symbol, because it's a pattern that reoccurs everywhere for us.
Okay.
What is then happening, and this is actually another pattern that we used multiple times later on as well, is that if you actually want to have multiple consumers, SQS is not the best thing to have, actually, because once you consume a message, it's gone. So we actually need to have something else to fan out, and this is where SNS is actually perfect for, because messages end up there and you subscribe to them, and it's basically like a small event bus again. So you can have sort of a pub-sub where you can have multiple consumers who see the same messages and who have their own state of how far they actually are with the consumption. So basically we have then, once we have these raw files, which are just like split of one line as one record, and that's pretty much it. We have another Lambda which prepares the meta information again to be consumable by multiple downstream processes. One, which is the biggest one here, is the repartitioning, which is what we are offering to all our users, because the standard how users expect the data layout to be is that it is partitioned by the time that the events actually occurred. So there has to be some time partitioning, which is not the default case. So we are actually having this repartition Lambda where we basically again read all these files and repartition them by occurred at date. And this is how they end up in what we call the data lake main bucket, where they then become available to our users, for instance, via Presto tables.
Yeah.
One interesting use case for the other side here is that now you actually allow multiple people to hook into the same messages. So in this we actually heavily use for binary conversion. Binary conversion has the small problem that if you actually want to convert something to binary format, you need to have a schema already. And that is why we ask the users who want to have certain event types, certain topics in binary format to actually bring their own schema. So they have to come to us because inference is one thing that we can do, but it will it's always fuzzy. There's always problems that you have with that. We did that for a long time. There's always issues. So it's always better when you have the users who actually know the data be the ones who bring the structure to the data.
Yeah, that's true.
Yeah, and we allow them to then subscribe to their specific event type. So that's a nice thing about SNS, because you can actually filter on some of the messages. So we allow them to subscribe just to one specific event type, or to multiple if they want to. And on that side, then apply the binary conversion for these particular event types. And this is where we're using SNS for the fan out of these messages is really coming in handy.
That's really clever.
Yeah, and it's more and more important to kind of delegate those aspects like schema management to the users or consumers or producers, because we are in between, and that is like, let's say, central data infrastructure team. We cannot be expected to understand thousands of data sets, right?
That's true.
We offer means for other teams to publish or to consume the data, and we are trying to distribute the work also among them in terms of data quality. So we offer them a generic pipeline that they can configure with a pull request. The pull request is going to contain the schema definition and certain function definitions for the underlying processes that are done with Spark. And we then deploy it, and they, according to this pull request, the consumers now can consume a new version of a certain data set that they defined. So we are delegating it as much as possible as well.
Yeah, but as you said, that makes sense, because the ones who knows the data sets or what they want to do with them the best is the actual department who is going to use the data.
Yes.
And so I'm guessing that it would also not only be a terms of you don't know exactly what to do. It's a problem in terms of volume, that so many people want to do stuff that you would need a huge central department to do all this stuff.
Yes, and actually, so this is why we try to actually decentralize, which it sounds interesting, maybe paradoxical in the context of a data lake. However, certain aspects of it have to be decentralized, because there is knowledge about data sets that is always local, right?
Yeah.
And especially for transactional data that has a structure that changes very often. And then you have to somehow handle things like schema evolution, like schema conflicts, and so on. We cannot do it. We are a team of 10 people now, and we have several large components to maintain, thousands of data sets. So we are like the bus, right? We are the infrastructure, and try to definitely push as much of this work as possible on others.
How much can the department do by themselves? Can they do updates by themselves, or do they need you for that?
They can update the schema. They can update schemas with pull requests. We still need to do like additional deployment of some of the components, but it's not that time consuming, right?
I'm guessing.
Yes, and we are going into this direction more and more. So pull requests for us are like entries into the database or API calls. So when somebody does a pull request, it is like an API call with, let's say, a JSON object. Please do this operation. And we do it with pull requests because we are working according to the principle of infrastructure as code. This also means that a lot of configuration instead of a database is being kept in repositories, because this offers us two main advantages. First of all, we let others modify this configuration without our involvement outside of basic review. And the other is auditability. We have a full audit trail of who requested what, when. And one of the aspects that we didn't mention is that Zalando is a publicly traded company, a pretty large one, profitable, which means that it is a great target for any types of audits and And yes,
Yeah, but
I
it
mean,
sounds funny, but that's a real issue. That's a real issue to have it
yeah.
everything traceable. Who changed what and
So,
when and
so as consumers, of course, we are very happy that we have regulations like GDPR because our personal data is much better protected. But as data engineers at Zalando, we are also on the receiving side of it because we are trying to adjust our infrastructure in a way that is fully compliant. And this is pretty challenging as well, yes.
yeah, I know. I have gone this route. Did this.
Yeah.
This is not always fun.
I will maybe switch to the next slide, which is
Yeah.
pretty similar, and it shows another pipeline.
This is the relational data pipeline that we've been talking about. So the pipeline that actually gets the data from the data warehouse, which is still running in a data center. And what you see here on the slide is pretty much just the control plane. It doesn't really show you what's actually happening. So just to describe this in a few words, we are, as Michael already said in the beginning, we are having like 300 tables which are still sitting in the data warehouse in the data center that we want to copy over to the data lake. One big limiting factor is here that you cannot just copy all the data every day to have all the updates, but instead we are just copying change sets so that you basically have a snapshot on the data lake side, and then you just extract the increments of everything that changed since the last extraction that ran, and then you merge it with the previous snapshot that you had and create a snapshot on the data lake. And this is basically what you see here on the control plane. It looks very similar then. The first thing is that we have the communication about which table can be extracted when via the company by the event bus again, so via Nakadi. This is where from the data warehouse, we basically get an event that tells us table XYZ can now be extracted. And this then triggers our pipeline, right? What we then have is again a Lambda, which is continuously polling for these messages and then actually filling an internal queue again, which starts the whole process on our side. So we have a Lambda again, which prepares all the input that is necessary. So it fetches the parameters which are specific for this given input data set, like merge keys, time keys, these kind of things that you need to actually do the extraction. And then we use step functions to manage the whole extraction. Because one pretty interesting thing here is extractions and merges both usually take longer time than what Lambdas can do. So you actually cannot do your processing just with Lambdas anymore because they have limiting factors. They right now, even though it's increased already, have a maximum runtime of 15 minutes. So your longer running processes you cannot do with Lambda anymore. That's why we are using Spark here. And again, as Michael said in the beginning, we are using Spark as managed by Databricks, which comes with some nice interfaces and some nice additions to the system. But basically what we're doing is we're running a step function which manages the Spark job. How does that look like internally? There is one part of the step function which starts the Spark job. And then basically in the step function, we have a loop that constantly checks the status of the job. And once the job actually completes, you get the notification that it's now done, and then you move forward. So once the job completes, you have your incremental data set now on S3. So you move to the next step of the pipeline, and the next step of the pipeline looks exactly like the first step again. It's basically the exact same thing processing-wise. So you again have a queue, you again have a Lambda, which does the preparation, which fetches all the parameters, which depend on the data set. And then it again triggers a step function, which is again managing a Spark job, just that the Spark job now is not running the extraction, but actually merging what has already been extracted with the previous snapshot. And after that, we actually have some what we call signaling to the world, which is by now even a bit more sophisticated system, where we basically tell the people now this data set is available in the data lake, and you can now use it for downstream processing.
Yeah.
Maybe 1 minute about step functions, because this is a component that has been introduced on this slide. So those 3D square icons are representing step functions. We use step functions in where otherwise you could use, let's say, Apache Airflow, right?
Yeah.
So functions are like serverless state machines that you can define with a pretty simple language. And they are a way to have basically a workflow that is not necessarily like, so in Airflow you have directed acyclic graphs of tasks, right? In step functions, you still have a graph, but it can be cyclic. So it is, and you have states and state transitions. So you have a state machine. And on every state, you can say contact Apache Spark and wait for a job to finish, or trigger a lambda, or do something else. And this way, you can have a pretty easy to deploy and define, but also completely serverless way of managing workflows in your data pipelines. So we started at some point with Apache Airflow, but it didn't scale to what we needed because
Interesting.
of the scheduler in Airflow. And step functions were a really fantastic way to replace it. Because what we are doing now is essentially we have two definitions of step functions for this pipeline. However, every step function execution can be parameterized, which means that it can do slightly different things or take care of a different data set, right? Which means that we have two definitions that can easily serve hundreds of data sets based on the parameters that we provide to every execution. And as every resource on AWS, you can fully monitor them. You can use CloudWatch. You can use AWS APIs to extract information on the state of each execution. You get very detailed information about the status of every execution. If it failed, you will know when, where exactly, and how. So as a, let's say, serverless replacement for scheduling systems like Uzi or Airflow, they work very well provided that your workflow is pretty simple. And pipelines can be actually pretty simple. Our pipelines are quite simple, but they are very wide. So they horizontally expand quite a lot. Yes. And this is where step functions like really help.
Okay. How do you configure them? Do you configure them with something like a JSON or an XML?
Yes, there is this Amazon state machine language which has a separate website, and you configure it in the same way as every resource on AWS, which means that you can include it in your CloudFormation template or use Cloud Development Kit, write this definition as code, commit it, and then deploy with like continuous delivery on any system you have at your company.
I think that's a good time as well to drop some words about CDK.
Yes.
So the Cloud Development Kit that Michael just mentioned is a pretty new open source project by AWS. Which just started about like 8 or 9 months ago or so. And it's basically allowing you to have an abstraction layer on top of CloudFormation templates, so that you can actually write your stack definitions as code. And this is like really powerful because at first it's using something which they call smart defaults, so that you don't have to specify every parameter anymore, which is just using the default value anyways. So you actually just specify what you really need. And this also allows you to simplify your infrastructure a lot. And then writing it as code means that you really just, you have your IDE. We are using mostly TypeScript for this, so we are running on VS Code. And you just write your code, which is basically telling something like create a Lambda function and point to a specific artifact on S3. Now you create a queue and you attach this queue to the Lambda. And that's like 3 lines of code. And this is like really powerful and really helped us to scale out this a lot. Because just a slide that Michael showed recently, if you put all these details together, you have like, I think something like 47 different components. And using a CloudFormation template to define 47 different components, that's a lot. It's like it getting really messy, and this is like a lot of lines that you have to write. And actually doing this with CDK, it took us about 1.5 weeks to develop that thing, and it was in the end like 300 lines of code.
Yeah.
So much better, so much more useful, and so much easier as well to do all these things and put these all together. And the cool thing again is that it's even on top of that taking care of all the permissions. So if you like create a Lambda which needs to read from a queue or whatever, you just attach it and then you get the permissions for free, basically. So it automatically makes sure that you actually have the proper permissions to, let's say, read.
So it's higher level instead of trying to, instead of going to the documentation of this particular component that you want to connect, listing all the actions that it needs, and then putting it in the template of your, let's say, IAM role. You simply do something like Lambda can read from this queue, right? It's a one, and underneath the CDK is going to set up all the permissions. I have switched from the presentation to an example from AWS written in TypeScript, and this is like an example code for CDK. If we could if we could reference back to the pattern that we had before, Lambda plus SQS plus dead letter Q, you can have it basically as one class that you then just parameterize and add it to your stack now, right? Which is pretty amazing.
Sorry,
guys. Yes. So those higher level contracts that contain several types of components working together, you can now treat those as like higher level components and deploy them to your stacks. You can even, because this is, for example, TypeScript. So if you have, let's say, an internal repository at the company of components for Python or for Node.js, you can publish there so that somebody can do npm install or pip install and get this component right away and import it in their code. So you can publish like reusable components, infrastructure components to your internal repository and let others use them.
And we're actually doing something like this already. So there's one use case which we have where it doesn't matter what the code actually does, but we want our users to deploy one SQS plus one Lambda, which does something. So we actually just give them an instruction set of do npm install CDK, download the code that we have, and then just do CDK deploy. And then they basically deploy the stack on their side, and it automatically connects to our stack on the other side already. So even sharing the definitions for stacks on AWS becomes so much simpler with this. So this is really
that's really powerful. Can you send me the links so that I can put them in the description of the video? To them?
We are going to send a set of links.
Yes. One thing to mention, by the way, is that actually CDK right now is not even in GA yet, but we are already using it in production pretty much. But they will release it to general availability very soon. And so far I can already at least recommend looking into it, if not starting.
But please don't tell anyone. We could move to Delta, right? Because it is an important topic.
Yes.
So this is okay. We have a very generic slide about something called Delta Lake. We still call it Delta because this is the first name that Databricks gave it to it. It is so Delta or Data Lake, now open source, is a table format. It's a big data table format that is based on Parquet as the underlying storage and a thin layer of metadata that is stored in the same location as the data. And with some additional components, what it offers are certain ACID guarantees that you normally expect to have from like more traditional databases like Oracle or PostgreSQL, right? So with this format, you can have similar behaviors like, let's say, snapshot isolation or transactional rights or non-conflicting updates, or let's say ability to read an older snapshot while a new write transaction is being executed. You can have those things in, let's say, like Hadoop big data ecosystem. This works well, of course, with Databricks runtime, but as an open source format can be used now with the open source version of Spark as well. So actually, Max could tell you much more about how it is used in the relational data pipeline, because we are using it heavily there.
Yeah, so like one of the interesting things is that what I told you before about the extracting these increments and then merging them with the previous snapshot. For us before that, it always meant that we had to create a new snapshot. One of the cool things here is that you can actually have an update for your files. So you actually say you basically have an upsearch of your new increment, and then Delta figures out for you what are the files where actually something changes. It writes new files with the updates while still having the old files there. But just by updating the metadata, you basically now tell that this file is not active anymore, but the new file is now active. And there are cleanup operations, so you can actually say, okay, now you completely clean up, which again makes your raw files basically be just Parquet and be readable by anybody else. But the cool thing here is if you're actually able to understand this metadata, you even gain a lot from keeping this history around, because now you can, as Michael already said, have a look at how the data looked like 2 days ago, for instance. So you can really fix your snapshot, and you can do time traveling on your data, which specifically for machine learning use cases is super valuable, because you actually need to have like some immutability on your data sets that you're using for training your model. Because if your data constantly changes, you will never be able to rerun an experiment and actually have the same result after all. And this is like a very powerful feature. And on top of that, you gain a lot in terms of performance, actually, because one of the most expensive operations when you do data processing on AWS is file listing. So when you actually want to figure out what are the files that you need to process that are lying on your S3 bucket, the first operation you always have to do is to list all the files. And this is a very expensive operation. And the cool thing here is now that you have this additional metadata, which in one small file actually tells you what are the files that are currently active, you don't have to list them anymore, because by just reading this file, you already know what are the files and you can directly address them. And this gains you a lot in terms of performance when you actually want to read this.
Okay.
And the cool thing here is, like, it was just open sourced, I think, around a month ago at the last Spark AI Summit. So this is pretty fresh. We have been quite lucky because we've been using Databricks for about a year now, and it was already part of that offering. But in terms of that, we've been pretty lucky to now come to the position where it's actually open source, where we can talk about how we already used it in the past, and how we very much benefited from that. And many other data processing platforms already have at least roadmaps or already actively working on integrating it as well. So there's, I'm not sure like what's soon coming, but there are several other ones which are already working on that, where you would benefit a lot. Let's say if, for instance, Presto would be one of the examples that we are heavily using. If they would have this integration here as well, then we would directly benefit from having this here as well. And by having it open source, this is one of the next cool big things to watch out for, I think.
Yeah, it's always when stuff starts to getting open source and it's good, then it's going to take off.
Yeah,
it's going to take off and be. Yeah.
We expect like an ecosystem to grow around this format because it is pretty widely adopted now anyway, at least whenever you see the Databricks distribution of Spark at the company. And it offers like really good benefits. And like you can see that it is a problem that like the problems that the Delta Lake solves are repeating themselves at many companies, because you can see companies trying to develop something similar. Like for example, Netflix and something they called Iceberg, which is also as like a similar solution, but I would say it's not as production ready as Delta. But same issues, listing of the files, snapshot isolation, and so on, and all those guarantees that are not currently present in most of the like big data deployments, however we would define them. Yeah. We have, because
How's the time right now?
It's 10.
Yeah.
That was not the question. So do we still have some time to talk about something else, or
Well, you said you have to leave at 10, so
So I think we could maybe because we presented what we have more or less,
Yeah.
but we could
okay,
present where we are going to, right? Where we are going to
okay,
put infrastructure in the future.
yeah,
So from the centralized data lake, we start moving towards something called federated data lake. And this means that
Mhm.
instead of just moving data, we let others bring data by simply exposing it to the central like data processing infrastructure. So if you have a bucket with a data set, you do not have to anymore copy it to the central bucket, which doesn't always make sense. What
yeah,
we need is to just let our processing components like Presto or Databricks access it and catalog it, right? And from then on, it is part of the data lake. So the data lake itself is becoming a distributed system. It's the storage is
that,
distributed. You can bring your data by exposing it to our infrastructure. And the only thing that is common for all the buckets that are being exposed is the metadata layer around it, which means discoverability of the datasets, descriptions, schemas, ownership, data lineage, all those
yeah,
elements of metadata. And another layer that is not necessarily mentioned here on this slide is also the authorization layer, of course.
yeah,
Once
yeah,
you start federating, you need to have a solution for federated permission management as well.
yeah, for the governance of the
Yes,
whole
exactly.
thing. Yeah,
And this is where we are moving to.
yeah. It makes sense because when most of the stuff is already on a cloud platform like AWS, then why not, right?
Yes, yes. So instead of copying the data, we just bring the processing, the computation to the data, but treat all of those like spread around distributed buckets as one storage
Hmm.
that can be used by others to access the data, process it.
And the
That's
interesting
cool.
thing is that like some of the centralized components, they are not gone all of a sudden, right? There will still be a centralized storage for some of the data sets. For instance, the data that gets centrally archived from the event bus, it will probably be like that forever. Yeah, so
Yeah,
that not everyone needs to bring their own data for every small data set that they have, but there's some form of centralization still, as well as the processing platform. Like as long as it's managed by us as a centralized team, and not only having like Databricks as a processing platform, but also having Presto. Providing that to others again means it's running under a centralized hood. But as Michael mentioned, you basically bring the computation to the data. This is the
yeah,
more important part here.
yeah. Yeah, the cool thing is that you can basically have departments that are doing some stuff. They are setting up their own RDS, and I don't know, make a web interface, the internal stuff or whatever, and then they can say, okay, let's connect it to the federated data lake and let's do some analytics on top of it.
Yeah, exactly this pattern could be pretty easy achieved with Presto. So let's say you have a valuable data set in a PostgreSQL database, right?
Yeah,
What you can do is configure like the central Presto to access this PostgreSQL, and then have this PostgreSQL table as just one of the data sets available with all the others through Presto, right? That's one of
yeah,
the ways you could do that. Yeah.
very cool. That's I'm guessing this is what we're going to see in the next years on a lot of or from a lot of companies.
Yeah, it's like, monolithic applications got turned into a bunch of microservices, and now we will have like those federated data infrastructures essentially at larger
Yeah,
companies. This is definitely something that will happen, I think, yes.
And
yeah,
one of the things that we also realized over time is that to get the data available to others, the entrance barrier has to be as low as possible. So you can
yeah,
always try to run like big central initiatives to get all the data into your data lake, and you will succeed to some extent, but there will always be some things that you miss. Some people where the effort is just simply too high to do that. So you have to actually not try to force them to bring the data to you, but you have to develop a concept where you go to them and you pick the data up from where it is already.
yeah, yeah.
Yeah, I mean, as data engineers, we want to see as few data pipelines as possible.
Your
Yeah,
pipeline is the less
Exactly.
things you maintain.
Yeah.
Huh. Okay, guys.
We should.
That was interesting.
So
Thanks.
we would love to talk more, but we have our stand-up. We should
Yeah.
get the team updated about what we are doing, not
Yeah.
necessarily now, but in general. There
Um.
are many more topics that we could talk about, of course.
Yeah. Thanks, guys. Where can people find you? Where can which social media platform should I send people? You want to go to?
So there's a couple of interesting things. Like one thing that I would actually love to mention, which is about the data engineering community that we are also running. Like first of all, data engineering is not just about building pipelines, right? It's also about actually building a community and getting people together. We do this internally. We have like a community of interest inside of Zalando, but we are also doing data engineering meetups, which are open to the public. And this is actually quite interesting because a friend of yours was at our last meetup, and that's how we actually got in contact. And we are doing these regularly. Next one is on 20th of June, so it's just 2 weeks from now. I'm not sure if the
Okay.
video will be up in time, but and we are doing these regularly. Besides that, we've been to a couple of conferences recently. Maybe I can share a couple of links of our latest talks, as well as some links to our like Twitter and LinkedIn.
Okay.
Yeah.
Okay. Great. Then I'm going to promote the meetup. Maybe we can get a few people more in there.
Perfect.
Would be great. Yeah.
Thank you very much.
Yeah, the community for me is also one of the important things here. That it's not only a few people working here and working there on that. So the communication is super important.
Sure.
Even what we have inside of Zalando is like, sure, we have the centralized department, but that's not the only place where data engineering is actually happening, right? You have a lot of data engineers which are embedded in certain teams who are working on very specific problems that are just solving like issues for these specific teams. And they are much broader set up than just our centralized team. So it's really important for us as well to like get all these people together, have proper ways of like sharing knowledge, sharing how to actually use these kind of infrastructures, how to do things together, and also learn and understand their use cases as well.
Yeah. Okay. I won't keep you any longer, guys. Just one more question. Just one more question. Thanks so much for being here, for being the second guest and on this channel and showing this super interesting stuff about Zalando and your platform and your pipelines. So thanks a lot.
Thank you very much.
Thank you for having us.
Yes.
And let's stay in contact.
Absolutely.
We'll do so for sure.
And thank you everybody for watching in advance.
Yeah, I'm going to try to I'm going to mention you in the LinkedIn
Okay.
in the LinkedIn post.
We are
So
going
maybe some discussions arrive.
Yes, and we are going to go ahead, like follow up with like relevant links, let's say. Okay.
Yeah, that would be great. That would be great. I'll have to share those. Okay.
Okay.
Guys, bye bye. Have a great day.
You too.
And a fun stand up now.
Yeah, we will.
Bye bye. Bye bye. That was interesting. That was really interesting. Yeah, what they are doing here on AWS, and AWS always amazes me how fast they move forward and innovate and make it easier to configure stuff. That's amazing. Check out the links in the description and look out for comments, or write a comment if you have a question. Write a comment to this video or on the LinkedIn post. I'm going to be doing when this video is up. It's the first one. This was an offline. I didn't stream it, because I wanted to try something out, and 9 o'clock in the morning. Yeah. Okay, guys, thanks for watching, and see you tomorrow or later today. Let's see. Bye bye.